I'm going to talk about reactions of alcohols and the different things, protecting groups, some special reagents as well, uh, and the whole set. So this is like an intense session, right? So coming in, I expect you to kind of know what these things at least looks like, and just kind of use this as a study session, because you could actually do a bunch of things with alcohol, especially in OrChem 1 or Chem 2. You learn a little bit more about these wonderful components. So let's start. So what if I were about to give you this alcohol here, right? And I added sodium bromide. What would be the product? What would be a product of this reaction? Well, this will give me no reaction. Right, again, my alcohol needs protonation. This is actually a terrible leaving group, right? And there's no proton source, therefore this cannot get a hydrogen to kick off water as a leaving group. So this will give me no reaction. However, if I take the same molecule here, right, and I'm going to react this with, this is called a protecting group. So for those of you guys who want to look like who guys want to know what the molecule looks like, it's a handful. All right. And this is usually in pyridine, which is some sort of mild base. And what this is, it's a protecting group for alcohols. This is a protecting group for alcohols, right? And usually you'll see it abbreviated as TSL, right, or tosyl chloride. This is a protecting group for alcohols. And what it does is that it protects your OH group, and so it makes, that group now a good leaving group if you want to perform some sort of any reaction. So again, if I react this alcohol here, this protecting group here, here's a product that I get. I get OTS. All right, and that's just another name of saying my alcohol is protected. So this would be the product that I would get. All right. Now remember, if I have an alcohol, right? So remember I said that starting with this reaction, right? So remember I said that starting with this reaction here, right, and adding sodium bromide, these will actually float in solution. Nothing would happen. There's no reaction, right? But hey, if I wanted this reaction to occur, what I could actually do in the first step is add my tosyl chloride in pyridine. And usually, if you guys want to know what pyridine looks like, just say mild base. This is what pyridine looks like. And reacting this alcohol with this, here's what the product that would give me. I'm just kind of reiterating this. It gives me OTS. And now I could actually add sodium bromide, right? Bromine serves as a nucleophile. This is prime for SN2 reaction, kicks off my tosylate group, right? And now I get my neutral product, which is what I hope to form, to form initially, right? So that's just something that just to keep in the back of your mind. Now there's a special reagent. It's kind of hard to deal with though, but there's a special reagent, right? And you'll see it abbreviated as Pbr3, right? And what this does is that it actually just replaces your alcohol, right? And you get your bromine. You go straight to the bromine. Now remember, adding sodium bromide initially, we got no reaction, but this reagent is very useful. It's a special reagent. So remember, this just gives you automatic bromination, right? So it kicks off your alcohol and you get a bromine there. So this goes straight to the product that you're looking for, right? Now, cyclohexanol here, right? This is also another protecting group. It's abbreviated as TMSCl, and usually you see it in um, some sort of solvent, some sort of base. And here's the product that you get. You get OM, you get OMS. All right. Now, for those of you guys who want to know what the molecule looks like, TMSCl, it looks something like this. It has a silicone in the middle with a chlorine, CH3, a CH3, and a CH3. So this is what it looks like. This is what it looks like, right? And then to kind of show you a brief mechanism of what happens, right? I have my cyclohexanol here, right? My oxygen on lone pair, silicone in the middle, chlorine, my CH3s around, right? And my oxygen actually act as a nucleophile to attack the silicon atom and kicks off my chlorine, right? And this is what I get. I get O that has a positive charge now because of 3 bonds and 2 lone pairs, right? And it's now bonded to this whole molecule here. Right. But this is the reason why we add this base here in the middle in the second step, and it looks like this. Nitrogen has 2 electrons, right? And these ET groups around my nitrogen. And what it does is that it acts as a base, which it is, takes the hydrogen, kicks off back on the oxygen, right? And you get your neutral product, OTMS, which I'm just going to abbreviate. So that's another protecting group. So this is another protecting group. So far you've learned about 2 protecting groups, tosylchloride and then TMSCl. Now there's another protecting group, and we kind of use it every day in our cars, but we actually didn't know that it's really useful in chemistry when we're protecting alcohols, right? So, and this is ethylene glycol. All right, ethylene glycol. Now, ethylene glycol protects ketones and aldehydes. Protects ketones and aldehydes, not esters or carboxylic acids. So not esters or carboxylic acids. Carboxylic acid. You know what I mean, Ken? Right? Not esters or carboxylic acids. And usually you kind of use ethylene glycol in some sort of acid workup. So what if I give you what if I'm about to give you this molecule here? And I added ethylene glycol. Now, ethylene glycol is a diol, so it looks something like this. All right, and I'm going to add some sort of acid workup in the second step. Here's what I get. All right, remember we said it's good for ketones and aldehydes. So I'm going to get 2O with 2 carbons bonded to it. All right, so, and this would be a product that I get. Now, remember initially we said that when we learned about lithium aluminum hydride, we said that it's a strong, so it reduces everything, right? If I were to take lithium aluminum hydride in the first step and then water in the second step, I would get no reaction. And think of the reason why. Right? Now this alcohol is protected. So this is why protecting groups are important. And so that's the third protecting group you've learned so far. So that's a protecting group. So maybe we should take a look at the reaction, right? Let's do some examples. All right. So if I take this molecule here, right, and I added ethylene glycol, OH, and some sort of acid workup, what would be my product? Well, notice that this is an ester. Ethylene glycol is not strong enough to protect esters. So therefore, I will get something that looks like this. And again, this video is just is pertaining to just the general reactions of alcohol that you will need to know. So your protecting groups, uh, just general reactions in Orchem 1 that you will need to know. Right. So this will be the product I would get. It's not strong enough to protect esters. Right. Now I could actually carry out a synthesis with this reaction. So what if I take this molecule here and react it with lithium aluminum hydride and then water in the second step? What would be my product? Well, again, this is protected. But lithium aluminum hydride reduces everything, right? So I would get the product to look something like this. I get the product to look something like this. All right. Now, in order for me to deprotect that alcohol, in order for me to deprotect my, right. So in order for me to deprotect my alcohol, the only thing I could do is add acid, right? All right, or not deprotect my alcohol, but deprotect my ketone rather, right? And I think I've been saying alcohol all along. But remember, ethylene glycol protects ketones and aldehydes, not esters or carboxylic acids. So in order for me to deprotect my ketone, I could just add acid, right? Which is the same thing as H plus in water, right? And I'll get my product to be something like this. So this is how I would carry out a synthesis. Get into this molecule. So maybe your professor might ask you to carry out a synthesis, right? So what reagents would you use? Well, this would be exactly what we would use, right? So that's a very important point. Now, let's talk a little bit more Grignard reactions. So what if I were to take this molecule here and add magnesium bromide, magnesium in this first step, and then acetone in the second step, and then acid? What would happen? No reaction. All right, no reaction. Because look what would happen. I'll get my magnesium bromide here, my alcohol, right? This bond is ionic, so this is a plus charge, right, on this bond. So therefore my oxygen is negative, right? Now, remember, the rules for Grignard reagents is that there should be no protic species. Right, and essentially what is happening is that when you have protic species, you're essentially just the molecule is just gonna react with itself, and you're gonna get an oxygen that's deprotonated. So that's not good. So what you want to do to carry out the synthesis, and I think I'm going to have to stop this video here. So if you're interested in just the general reaction of alcohols and how just the overall general view of what you need to know, then part 2 of this video will be coming up, and we're going to synthesize this reaction to get a particular product. And then we're also going to learn about another protecting group, which you should know.